mean and the standard deviation of our sampling distribution given the sample proportion. However, we should also know that when we are doing inferential statistics, we are basing our conclusion about the population from our sample. So we really need to be careful in working with the formulas that we're using in determining our mean and standard deviation in answering some probability questions or questions about our sample. Now, to review on the formula in finding the mean and the variance of our sampling distribution given the sample proportion, the mean of the sample proportion is basically the population or the given population proportion itself, and the standard deviation of our sample proportion is given by this formula, and the formula is the square root of PQ all over N. Now, before we can trust our formula in answering some questions about the population based on the sample, we need to satisfy conditions in our formula, and these are the rule of thumbs that you need to satisfy before we can proceed in answering questions about the population. Now, the first rule of thumb for sample proportion, once again, this only works for sample proportions because we have two sampling distribution, the sample proportion and the sample mean. Now, for sample proportion, the first rule of thumb is that the population should be greater than or equal to 10 times the sample size. So this first condition needs to be satisfied before you can proceed to your computation. And the second rule of thumb is n times p should be greater than 10 and n times q should be greater than or equal to 10. Now n is your sample size and p is the given proportion in our problem. Now if these two conditions or rule of thumbs are satisfied, then we can proceed to answering our word problems involving sample proportion. Here's an example of a word problem or inferential problem in statistics wherein the sample or the population proportion is given. Now, a factory employs 3,000 unionized workers, of whom 30% are Hispanic. The 15-member union executive committee contains 3 Hispanics. What would be the probability of 3 or fewer Hispanics if the executive committee were chosen at random from all the workers? Now here, if we're going to organize our givens, n or the sample size here will be 15 from the population of 3,000. And the population proportion is given by 0.30. Now to answer the question of what the probability of 3 or fewer Hispanics will be in that committee, we need to perform our normal distribution and find its probability by finding the mean and the standard deviation of our sampling distribution. Now, before we can do the formula, use the formula and perform the probability procedure in answering the question, we need to verify the rule of thumbs first because we don't want to waste our effort only to find out that we cannot rely on our result because it did not satisfy the rule of thumbs. So the first verification is the rule of thumb number 1. The population should be greater than or equal to 10 times your sample size. And we know that the population in this problem is 3,000, which is greater than 10 times 15, which is your sample size, and it is satisfied because 3,000 is greater than or equal to 150. So this inequality is satisfied for the first rule. So now we can proceed to rule of thumb number 2 to see if it will also be satisfied. So for the first part of our rule of thumb number 2, we should verify that n times p is indeed greater than or equal to 10, where n is 15 and p is 0.30. When we multiply this 2, it gives us 4.5, which is, we know, not greater than or equal to 10. So the first part in our second rule of thumb is not satisfied. So even if the second part of our rule of thumb number 2 is true, which is 10.5 greater than or equal to 10, we still cannot rely on our judgment or our computation of this formula because it did not satisfy one of the conditions in the second rule of thumb. So we can basically answer the question using our formula. However, you don't want to waste your time doing that because we already know that we cannot rely or we cannot trust our conclusion because it did not satisfy the rule of thumbs in our sample proportion.